Dear viewers, today I am going to show the advanced BLDC drive developed by National-Infotech. So this is the full setup of advanced BLDC drive. So first of all, this is the 3-phase inverter high power module. So you can see the connections. This is the input section, input supply section, rectifier section, DC link capacitor and 3-leg inverter. Okay, and this section is for the output. Okay, so you can connect motor here, you can connect the auto transformer output here. Okay, and you can connect the short links for the positive rail, and you can connect the short links for the negative rail. Okay, so you can, by using those connection, you can make the 3-phase inverter. Okay, and this section is here, you can connect the gate pulses for H1, L1, H2, L2, H3, L3, 5 volt and ground. And this section is for the sensor, AC current sensor, and for one is the DC voltage sensor. Okay, so DC voltage sensor is connected in here. Okay, and the current sensor is connected here, output side. Okay, and here you can see the gate pulse is GA dash, means H1 L1. Okay, and carefully you can connect the 5 volt and ground okay, from the controller. Okay, so now second part is the controller. So this is the full kit of the controller, rapid development kit. Okay, so in this section is the analog section, this section is the DAC section, timer 1, timer 2 section, timer 1, timer 8, 2 timer section, QI section, supply section, GPIO section. Okay, and here this is the display, LCD and keypad interfacing. Okay, and this is the PC, you can get it in this kit. And this is the BLDC motor, so 300 rpm, 375 watt, 48 volt BLDC motor. Okay, so this is the full setup of advanced BLDC drive. Now we will discuss the connections. Okay, so here you can connect the input supply. Okay, which is coming from the auto transformer. So you can adjust your input DC link voltage is 48 volt. Okay, and you can short all the positive side, and also you can short the all negative sides. Okay, and here you can connect the motor terminal RYB. Okay, and from here you can connect one port, analog, open loop and closed loop, both you can connect the same wirings. Okay, so you can connect one short links to port, analog port to ADC 0. Okay, and encoder wire you can connect on the GPI port. Okay, and one wire is there which is the speed sensor wire. You can connect this speed sensor wire to here, PA9 pin, QI section. Okay, and timer 8 you can get the gate pulses. Okay, so you can connect like this. Okay, PC6, PA7, PC7, PB0, PC8 and PB1. Also you can see here which is mentioned. Okay, so H1, L1, H2, L2, H3, L3, and 5 volt to 5 volt and ground to ground. And same wire you can connect here for the gate pulses to given to the inverter. So here you can connect the H1, L1, H2, L2, H3, L3, 5 volt ground, and this is the sensor output. So here you can connect the DSO and you can observe the current. Okay, so this is the basic connections for all the open loop and closed loop programming. Okay, so you can connect like that. Okay, and this is the motor. So from the motor you can get two wires. First is RYB and second is encoder wire. So RYB you can connect here and encoder you can connect here, and this is the PC. So this is the code for the open loop control. Okay, now and this is the motor. So now you can turn on this code, okay, and you can just press the Control B to build this code into the controller. So by pressing this Control B, it is done the code in the controller. Now we are starting. After dump this code, you can start your DC link voltage, and after dump this you can on this system, okay. So now you can see the code is done in this controller. So after completing, you can get this type of dialog box. So everything is perfect, then this is the green. So your code is perfectly dumped in this controller. So now we will discuss something, okay, it is important. So here is the open loop mode. Here you can see the direction of the motor, okay. Here you can see the on off control. It is control is on or off, okay. And here you can see the duty, and here you can observe the actual speed of the motor, okay. So by varying this port, you can vary your duty. So you can see when I am varying this port, my duty is varying, okay. So lower limit of the duty is set to 10, okay, 10%, and upper duty limit is set to 85%, okay. So now function of the key is on and off, okay. So first of all, key 5, by pressing this key 5, you can turn on and turn off the system, okay. By pressing this K3 button, you can change your speed direction, okay. So in the open loop code, two keys are on the functions on off and speed direction change. Now we have start the motor with applying the 48 volt DC, and we'll see the performance. So now I have applied the DC link voltage. So here I have applied DC link voltage to 48 volt here at the input of the inverter, so we can control the motor properly, okay. So now by pressing this button, so you can see speed is counterclockwise off position, and duty is at this time duty is 10, okay. Now I am by pressing this button, it is start the rotating, okay. So by pressing this button, you can see motor is started with the counterclockwise direction, and the applied voltage is 48 volt, okay. And you can see here updated display is on off, on, counterclockwise, duty is 10, and this is the actual speed. And you can see here the H1, H2, H3. So you can see actual speed is 272 rpm, and here you can also see our actual speed is also 272 rpm, okay. Now I am increasing this duty to 30% and see the performance, okay. So at 30%, at 30% my speed is 14, means around 1400 rpm, okay. And you can see the actual speed is 13, okay, 1295 rpm, and here you can see the actual speed is 1310 rpm, and here you can get the 1310 rpm, okay. Now I have applied it is no load condition, okay. So now I have applied this to load and check the performance, okay. So you can see the current is 5.6 ampere. So I have set this current to up to 7 ampere and check the performance. Okay, so now current is 7 ampere and my speed is decreased to 747 rpm, and also you can see here the 746 rpm. Okay, here you can also get the 746 rpm, and you can see the current waveform. Okay, this is the R for the first channel and Y for the second channel. Okay, now I am increasing the duty at the same 6.7 rpm. Okay, I am increasing the duty up to the maximum limit and see how much it is speed. So this speed is 2414 rpm, and the current is 6.6 ampere. Okay, so my speed is 2613 rpm, and here 2643, and you can see 2643 rpm. Current is 6.4 ampere, and it is working perfectly. Okay, now we have stopped the motor and change the direction by pressing this button. Okay, so in this condition you can apply. In the on condition you can press any key, it will not take any action. Okay, so compulsory you can turn off the system, then you can apply any action. Okay, so when I am pressing this off, motor is turn off. Okay, then you can change by pressing this button, you can change the speed direction. Okay, then you can start the motor. Okay, so you can see motor is started with the clockwise direction. Okay, so you can see, and current is at this time current is taken to 5.6 ampere, and speed is 2542 rpm, and you can see so you can see our speed is 2576 rpm, here 2576 rpm. Okay, so likewise this it is working with the open loop mode, and working in the both direction, clockwise, anti-clockwise direction, and see the current. Okay, so now second major things in this code is, if you have not connected the hall sensor, or in between the working of this setup, if this sensor is disconnected, suddenly the system is turned off. Okay, suddenly system is turned off, and here you can see the updated display, sensor is not connected. Okay, so you can connect the sensor first, and it is gradually increase your speed up to your last applied duty. Okay, so likewise this you can control your motor in the open loop mode. So this is the full function of the BLDC motor in the open loop. Thank you.